Hi, welcome back to class number 6 of Nuke Immersive VR Compositing. That's nuk234. And in class 6 today, we are going to concentrate all our efforts on our troll friend. We worked on the forest last week, and now we're going to put the troll inside the scene. And I'm going to go through a couple things, including how to set up some render layers. We had some questions last week in the forums regarding how did I set up the render layers, because render layers that I use are non-traditional. So I'm going to talk about why that is and what we're trying to accomplish by doing it this way. As well as we're going to talk about some different ways of increasing our resolution on our feature, our hero character, and we're going to go over the composite of putting all this together with what we did last week. So let's jump right on in. Now, what we have here is the troll, and he's been animated. And let me just pull up a play blast of that animation. Here we go. And the animation, he's pretty much sleeping, and then he jumps up. He sees us, he takes a swipe at us, he screams and roar, and then, you're leaving, so I'm bored, so he walks away. So the animation turned out pretty nice. I wanted to give a special shout out to the two people who helped me put this together, and that was Devin Zoltowski, who did the rigging of my character, and Alexander Lanos, who did the wonderful animation. So the two of you, thank you very much. What I provided you today is an Alembic file, an Alembic cache of this character. And that Alembic cache is being read into the Maya file right here and has some textures assigned to it. So if you open up the Maya file that I supplied you with, it's probably going to not have the default material on. It's going to look something like this, which is pretty nightmarish. Now, what's happening here is Viewport 2.0 is not quite displaying everything correctly yet. So what you have to do to see the textures is go into your Viewport 2.0 settings and regenerate all the UV tile texture previews. That's because he's being mapped with Mari UDIM UV mappings, and there's like 5 different tiles. So the display doesn't know how to display those until you create a preview, and that's on each file node. But right here you can force each file node to update and process. There we go. So once that's done, you can see that we have our character right here, but it's going to be a little bit more slow depending on your graphics card. Bear that in mind. And you can see mine's chugging along here. Choices in how much throughput I could get rendered for you guys. I included a good chunk of renders with the downloads today, but we are rendering at 4K in stereo with 400 frames. So it's a lot of throughput. My choices in the render layers aren't as expanded as I would if I was in a studio. If I was in a studio, I'd probably break out key lights and fill lights as separate passes, break out the RGB components, the specular components, the diffuse components, the subsurface components, the indirect lighting. There would be probably about 30 different passes per eye, and that takes quite a while to render when you only have one machine. So this is an optimized version to give you an idea, but that's also why I include the scene file so you guys can load it up, generate your own passes, and be able to render your own choices if you need to. All right, so I turned off the Viewport 2.0 textures so we can get a little bit of our interactivity back. I don't need to see those. They'll render just fine. But one thing that you're going to see is, you know what? Let me start this with a fresh scene, and I'm going to import the Alembic file that I sent you, which is called trollupdate.abc. If you just import that into a fresh Maya, what you're going to see is this is the Alembic file as it comes in, and it's got some of the PLC and the rigging that was there, and you can just delete both of these items, and as well as the face rig, because none of that is really included or relevant to what we're doing. You just need that geo and that geometry. Let's expand our 400 frames. There we go. There we go. So now you can see the animation. And the texturing of this is just, I've also included all the maps and such, but you can see that the geometry comes in as its raw cage unsubdivided version. This will also slow your Maya down a little bit, but if you select each group or the entire mesh altogether and do hit the 3 key, which toggles on subdivision surface preview, which only works in Mental Ray, well, also works in RenderMan and V-Ray, but that will put the mesh into the correct state. The only piece of geometry that I don't want to subdivide further is these vines that are growing on the surface there. If you subdivide those, it will cause some issues. So I advise not doing that. Another thing that I did with our troll is I slid the animation. We're doing about 400 frames here. And if we go into the attribute editor and we go to the Alembic node, you can see that there is a speed and offset. Under that, under speed and offset, we can change things about how it reads the Alembic cache. So for example, if I make it run at half speed, what's going to happen is it's literally going to move in slow motion. It's going to run at half speed, and the animation will go from 400 frames to about 800 frames. You can also make it go faster, and you can also offset it. Now, I had my animator, Alex, animate an extra second on the end, so it actually goes to 424 frames, and I started to really like that moment when he walked away, and I wanted to include a little bit more of that. So I ended up offsetting it by about 12 frames here. And that brought a little bit more of that movement into the end shot and adjusted some of the timings to line up better with my camera. So that's another thing that you're going to see in the final file. So let's open that file back up. Class 6 renders. Okay, so now we're back in our file, and what I wanted to show you is the render setup. So I'm going to go out to our shot cam right here, and we can see what it's going to look like. And I'm going to turn off the camera so we can see it a little bit better. And let's go to the channel layer editor. Now, there are inside of Mental Ray and other render engines the ability to go over to this scene tab, and we can generate passes. Now these are passes such as direct diffuse, indirect, direct glossy, all the way down to depth, normal, motion vector, position, which is PMAP, ambient occlusion pass. And you can use these controls to kind of deflect internal render passes out of the render engine into a frame sequence. And for me, these don't always work correctly. I like a little bit more control. I know what, as a lighter / compositor, I really know what I want to get. So I don't always want to have like a billion passes. especially when doing an online class, because you have to think about like how much data that you're going to be putting through. And while at FXPhD, we distribute a ton of data. I mean, last week I gave out like 8 gigabytes, and this week I think it's about 3 or 4. I still want to be very optimized in what I do. And that's why I also optimize the actual render passes after they get rendered. So directly out of Maya, I render everything as an OpenEXR. And under the scene tab, I switch my data type to 32-bit float, which is a floating point, and it's going to give me the most latitude in what I send out. It doesn't mean I'm going to send everything out as 32-bit images, but it gives me the ability to make a better decision about how I'm going to optimize things. But some of these passes are literally direct out of the render engine, and while technically on a bigger project I would like to have some of these, for this project I just don't think it's necessary. So I don't use this for this particular project. What I do is I use the render layer system. So if you come over, everybody knows what display layers are, but there's also render layers. And you can see right here, I've got my render layers set up. There's a master layer, which has everything in it, and that's turned off from rendering. That's what the gray box is. And then I've got my troll beauty pass. I've got a shadow pass for the troll. I've got a multi-matte, the Fresnel pass, ambient occlusion, and a PMAT pass. Okay, now I'm going to go over real quick how some of these are set up, but in a nutshell, the way you set up one of these passes is that you need to select the geometry that you're interested in creating a pass. So for example, we'll put together the Fresnel pass for him. And what I'm going to do is I'm going to select his object. I'm going to select the ground object, and I'm going to come over here and I'm going to select this button, which is going to create a new render pass, and it's going to include those pieces of geometry. So you can see up here at the top, it says layer 1 normal. I'm going to select that pass, and you can see that's the geometry that it included. All right, cool. So let's select this, and we'll call this a new Fresnel. All right, and you can see it doesn't have any lighting. It doesn't have any lighting because I didn't include any, and it's not necessary for this pass. Now the reason why is because I'm going to be using mostly surface shaders, which don't require lighting to be able to do this. So let's go into our hypershade and create the 2 surfaces that are necessary for this pass. First of all, we want a surface shader right here. And I usually call this one, and I use it all the time, as a black hole shader. And I'll just call it black hole surface. All right. Now this black hole surface is supposed to be set to black, 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 and matte opacity to black. See, everything is black. So this particular surface is being assigned to the ground geometry. And the main reason why is because there's a portion of his front foot and his hand that go slightly into the ground, as if they're like pushing into the dirt. So I want that ground to clip that portion of his geometry, so when it comps together, it looks correct, as if it did. It's a very fine intersection, but it's important when you're considering these things. Now the second part of this is creating the actual Fresnel shader. Again, it starts with a surface shader, so we'll call this Fresnel 2. All right, and where is our Fresnel shader? There it is. Okay, so it came down here. Okay, so select that, and we're gonna wipe the board clean and graph that. There we go. Okay, so it starts with a simple Fresnel shader. So let's just select all of our troll geometry and we will assign that to him. There we go, assign material to viewport selection. All right, so now that's all there, but now what we need to do is we need to create the Fresnel. Fresnel comes in two components. First of all, we need a utility, and that utility is called the sampler info node. So right there, see sample info. So let's create one of those. And we also need a 2D texture called a ramp. All right, so now we've got a ramp and a sampler info. Now the ramp is going to be using its facing ratio right there. Facing ratio, so things that are pointing towards us will be shaded one way, things that are shading away are another. So it's a facing ratio between the ratio of where the camera is pointing and where the surface normal is pointing. And because we're going to use this, we don't need a UV coordinate space for the ramp. So we can actually delete that 2D texture placement node. And if we open up the V chord and the U chord, I want you to notice that this is a V ramp. So because it's a V ramp, I'm going to take the facing ratio and attach it to the V chord because it's a V ramp. So select your facing ratio and connect it to the V chord. And now we're going to take the out color and we're going to send it to the out color of our surface shader right there. All right. And there we go. Now, when I select the ramp, you can see it doesn't look like much, but let's reverse the values. Let's send black to white and white to black. And there we go. That's exactly what we're rendering. This sort of effect right here, which gets the edges white and the middle black. And in Nuke, we'll be able to grade it to create much stronger silhouettes like that. But we want to render it with the most latitude, so we want to leave this 0 to 1 across the spread. And that's it. That's all there is to creating a Fresnel shader or Fresnel pass. Now, some of the other render layers, such as multimatte, those are just 6 different surface shaders assigned to different pieces of geometry of the troll. So that way I can select his eyes, select his teeth, select his skin, his fingernails, his horns, the rocks, the veins. Each one of these is a different surface shader. You can actually see it. We've got red, blue, and green, amber, magenta, and cyan, which are all the 6 points of color. Now, because I'm using the secondary colors of amber, cyan, and magenta, we're going to have to use a little expressions in Nuke or a gizmo to be able to filter those out. Traditional RGB mats, like I gave you 2 last week, because they just go red, green, blue, are very easy because you just intercept one of the 3 primary color channels. Magenta has a little bit of blue and a little bit of red in it, actually equal parts. So it's much harder to filter it out, but it's still something we can do. Then we've got our shadow pass. The shadow pass is simply the troll. All his objects are set to primary visibility to be off, so they're invisible. And the ground has a use background shader applied to it so that it catches the shadow in the alpha channel. Up here we have the AO pass, which is simply everything in there is set up for a ambient occlusion shader right here, which is the Mental Ray ambient occlusion shader set to out value to the color of a surface shader and set up to 96 samples. So it's pretty simple. It's just going to generate AO. And then the P map is very simple as well. Basically, it uses the same sampler info, but instead of facing ratio, we're using the info of point world. And point world is being mapped directly to the out color. And quite literally, if we understand this, it's mapping the X world coordinate to red, Y to green, and Z to blue, XYZ. So XYZ RGB. So it makes complete sense on how it's being done. And by doing it this way, I'm able to break out these passes across a couple machines and render each one of these as a stack. So let's jump over to Nuke and take a look at what our renders gave us. All right, so now we're in Nuke, and here are the renders that I provided. And what we have is we have our beauty layer of the troll. And you can see it's a stereoscopic EXR sequence, and I did what I could to make it as small and compact as possible. But I did leave it to be a floating point in linear color space. So if you switch it to sRGB, this is what it's going to look like when you render it in Maya, but I'm going to keep it in linear so that way we will have more color to play with. So I'm going to put a grade right after it, and I'm going to take the gamma down to about 0.6, 0.5. Yeah, that looks right. So that's the correct look for it, but this way we have all the color and it's not being clamped. And then we also have the stereoscopic render of the PMAP, which is right here, this EXR, and this has all the values. So that way we can put the same type of fog into our troll and to make him blend into the environment. And then I have my multi-matte right here. And you can see the multi-matte's got a lot of different colors to it. And we're going to be able to filter those out. And just like I said before, I was talking about how, you know, we've got the red, we've got green, we've got blue, but, you know, cyan and blue are both in the same pass, but as if you can hover the mouse over, you can see that this is 0 in red, 1 in green, and 1 in blue. So it's equal parts green and blue. So we have to write some expressions to get rid of that. And I'll show you what those are in a minute. So if we wanted to take just the blue out, what we're going to have to do is we're going to have to use a expression node and use an expression that basically takes 1, subtracts it from red, and 1 subtracts it from green, and then inverts it and adds blue, and then inverts the whole thing. And that ends up, basically, we also want to operate on both green and blue channels. There we go. So you see that brings out just the blue and gets rid of any of the cyan that would be polluting it and keeps it pretty clean. What I did was I downloaded a gizmo off of Nukepedia a couple years back that I use. I forget who made this. It's in here as a group node, and it does exactly what it says it will. So change the color, red, green, blue, and so on. And it also gives you options to either erode or dilate that matte and change the filter. That way we have more mattes packed into one sequence, a little more optimized. And then we have our multi-matte, well, not really multi-matte, multi-purpose pass, which has in the red channel our ambient occlusion, our green channel, the shadow, and our blue channel, the Fresnel pass. So we've got just like we did before. All right. Now there is a big change here, and that's what we're going to talk about next. And that is the shadow pass. I want you to notice that the shadow pass does not line up to his image. And there's a very important reason for this. Okay, the reason I did this is because if we take a look back at our comp over here, and when we have our shadow right here, I talked about last week, when we add the shadow back in to our passes right here, I want the troll shadow to equal the same color correct and density as this shadow. The reason that the shadow has to be different is because that shadow has to match this pass. And you may ask yourself, well, shouldn't they all match this? And yeah, you're absolutely correct. However, after doing some render tests this weekend, I discovered that I wanted to, here we go, change some things up, because on some key moments, and let's see, let's go to frame 260. There we go. So on a key moment, like the troll is swiping out at us, we are at the very apex of this shot. We are the closest to this screen, and he is reaching out in stereo 3D, and I felt like his resolution was very small. I mean, he's the hero of our shot, and yet in a 4K image, he occupies the resolution of 577 by 490 pixels. I mean, that was just like, oh man, really? That much? I mean, he was coming across in the final comp very, very soft. And while I can get behind the very foggy atmosphere of the environment being a little bit softer, I couldn't get past how low res that my troll was looking for the hero shot. I re-rendered that pass at 4 times the resolution. So instead of about 512 pixels, we're looking much closer to an image for just that character to being about 1200 by almost 1000 pixels. So this is basically like 4 times the resolution. And you can see that he's a lot sharper. Great. But how do we get this into the same mix? Well, and that's just it. And this is what's right here is I basically re-rendered the troll passes except the shadow pass under a new VDI correction of 0.39 instead of 0.19, which all the other passes was rendered with. This one's 0.39. And again, it's almost 2 times the length and width. Now, if I take this troll and I process this one, which was rendered at the smaller 1.9, and this one, which was rendered at 0.39, and I send them through the identical projection and scanline render. The only difference is this camera is set up with the 2.5641. This camera was set up with the 5.263. Okay, so when we look at this, we're going to be comparing directly the lower res render with the higher res render. And let's set up a wipe. And I want you to see the big difference is that these both put him in the same position, but you can see how much softer everything is because this originated as a 500 by 500 image versus 1200 by 1000 image right here. So we get a lot more bump fidelity and spec breakup, and the resolution's a little bit sharper. So it's still, not too bad, but at least our final delivery format, which is HD, he's at least being rendered out of like half that resolution. I mean, he takes up about 1/5 of the screen, but his pixel resolution is, about 1200 pixels out of a 1920 frame, and it's being downsampled, so it still looks so much better. Now, if we go to a earlier part of the film, say around frame 50, it becomes even more apparent how much softer this looks. Now, you can really see it on the edges right here. It's really bad. But he's got a little bit sharper look. We're going to have to deal with this in the comp and make sure that he doesn't look too sharp for the environment. And we'll massage that as we go and animate a blur over time. But at least we have more information to start with instead of being forced to only have this. So that's what's happening with that. Now let's take a look at the rest of the comp. The bulk of what we did the other day, or in class 5, is right here. And now this is adding the troll in over here. And the troll has the new screen correction math on this side. But we also need to bring in the new shadow pass. So back over here where we're comping this portion in here, and let's go to frame 260-ish. So we're further into the comp. There we go. When we bring in the new shadow pass, we need to bring it in right here, and we need to inject it into the already current passes. So when we bring that in, there we go. It's being merged right on top of the existing shadow, which is exactly what I wanted it to do, where the troll shadow should be the same density, same color, everything as the rest of the passes. So I have a 1 pixel blur here to make it blend in more beautifully. Merge is just merging that pass into what is already the shadow pass. So even though it's kind of polluting it all together, when we look at green, which is the shadow, we can see there's the existing shadow, and now there's the new shadow. And you can see we've got a couple different densities, but the grade node above fixes all of that and puts the same density all throughout the shadow. So it's all uniform. So then when we look at our color correct, the shadow is equal. And then this pass also gets sent out over to here as a postage stamp so we can use the other passes in the rest of it. Now there's another thing that we had to do special, which is the P map. Now the P map, as we know before, was being used for our depth pass. So I modified the depth a little bit so that way his hand was clear when it came out. So it's like coming out of the fog. And adjusted some of the color correct to deal with that. But that's great for over here, but originally our God rays were being injected into put on top of this pass, but what really needs to happen is God rays need to go on top of also the troll himself, so that way the troll is cutting out of the God rays. So to accomplish this, I needed to re-render a troll pass out of the 5.263 math of 0.19. So I read in the alembic file of the troll, and there is a time offset on him. So that way, so we've got the alembic here, and we did a time offset of -12, just like we had in Maya. So that way, this would be in the correct space. And then he's being rendered over top of black, just like everything else is. And this is not a subdivision surface, so it's slightly different, but that's okay because we're just generating some God rays. What I really wanted was an alpha channel that was correct. Now, I couldn't use this alpha channel because this one is much larger, so we had to use this one. So if we look at our God rays from last week, you know how we clamped in on it, created this shape, but now I've got a new shape of the troll blocking out the rays right there. So it's the same God rays, but now we've got the troll occluding some of the rays, which is really critical for the realism and integration. But in order for us to comp all this, I didn't want to make another one of these to transform this into the shape of the flattened out area or the view dependent image area, the God rays are being shuffled into a new image stream called God rays. And then it's being copied via the layer copy into the image stream. So that way, when this gets processed through the scanline render, and it gets view distorted, if I drop down to my other passes, we can see that the God rays are right there, also being processed by this same procedure. So instead of duplicating this again and running through another one, by injecting it directly into the image stream, I'm able to save and optimize a step by having that scanline renderer process it at the same time. And then the God rays come over here and get added on, but we'll come back to that in a minute. Let's jump back up here and talk about our troll. So the troll gets read in, and let's go back to RGBA, and I'm unpre-multiplying his edges and then grading him down, and I'm grading him down into 0.5 to put him into that sRGB space, but still give us that linear latitude to be able to push the color. The next step is multiplying on our AO pass. So the AO comes in and it gets shuffled out of the red and it gets multiplied on. So it gets multiplied on and we get this wonderful darkening inside his mouth and in the shadow creases that makes it look really nice. Well, since I unpre-multed the edges, now I'm pre-multing those edges to keep them nice. And you can kind of see what's happening right here. And then we have our other pass, which is our Fresnel pass, being shuffled out and then graded down to these edge pieces right here. And that's being used as a mask into a color correct, which is adding this kind of like dirt layer slash kind of this ambient orange color into some of the shadow areas. So it's still dark from the ambient occlusion, and it's keeping that dark inside his mouth, around his eyes, things like that. But it's just adding this little patina of color into there. And it's just, a little higher gamma, a little less saturation, and a tint on the gain. And then over here we have 3 multimats being used. I shuffled out blue for the horns, magenta for those eyes, and yellow for the teeth. And these next 3 color corrects are just that. This is the horn layer, which is just adding a little bit of blue tint to those horns, increasing their contrast and brightening them up just a little bit. And it's also brightening up some fingernails reflections and stuff. And then we have another color correct that just kind of brightens them up because some of these highlights are feeling a bit gray. And then this guy right here is adding in a little bit of offset to the shadows. You can see it's lifting the shadows up just a little bit because it wasn't quite looking right. And then we have a magenta, which is for the eyes, and I wanted to brighten those eyes up, make them pierce through just a little bit more. And I really like the red contrasting with the green. Those are complementary colors. And then with the teeth, again, just brightening up those teeth a little bit so they are a little more pronounced and scary. Now here's our P map, and we talked about how I was going to come back to that. And we added that in as a color correct to finesse it through. So you can see how we built up the troll from that or that to that. Now, I see a couple areas that I'm going to tweak some more for next week. And there's a lot that you can still do with this. but I just wanted everybody to know what exactly I'm thinking about before we move forward. So I'm going to take all of this stuff and turn it off. Then we're going to take a look at him comped into the shot. So you can see how he really stands out way too much here. So first of all, there's a very, very slight blur to give it a little better edge. And then we're going to go up to the top here and we're going to enable each one of these again. So let's take a look at what these do. So we can see how the multiply really adds that deepening of the shadows. And then here's that initial Fresnel pass to add that kind of color wash to the edges. And then a little bit more color and brightness to the horns. An overall color correct that pushes the brightness up a little bit more. This is the black level adjustment, making sure our blacks are not too dark. Brightening the eyes, brightening the teeth, and then this is adding in the fog. You can see right down here, you can really see how it's adding that little bit of fog into there. Cool. So now he's much more dynamic. Now down below here, after the merge, I have this edge blur set up so that way we get a little better softness across the border of the edge. And this is a really critical thing about edge blur, is that what you want to do, and this is why this shuffle is over here, is that I'm basically shuffling away the alpha channel that I'm getting from this. It's fully white. I'm getting rid of it so that way his alpha is there. So when he's comped over the background, that's our alpha channel, because this edge blur is going to use that edge as an alpha matte to detect the edges. And by doing this after the merge, it's going to actually blur the pixels across from background to here, creating a much better blur than blurring the edge and then merging over top, because it's blending across the pixels. And then down below that, this is where our God rays come back in. And our God rays come back in, and I had to bring an input out and back in as A, because the merge is not merging the A input. The A input is not RGB, but you can see the A input is the actual God rays, and it's being plussed on. So there we go. You can now see the difference. And notice how the light cuts through him as well now. So let's take a look at the final rendered sequence. All right, so now it's all buffered. Now check him out, sleeping as peaceful as a rock. And then we come and disturb him, and he jumps up, swipes at us, and oh crap, we got to get out of here, and we're gone, and he walks away. So very exciting stuff. Now, it's really cool because when he's down, sleeping like a rock, that's what he's supposed to look like. He's supposed to blend in like camouflage and look like he's a part of the forest. And so far, so good. Now, we're going to camouflage a lot of this even more, because in next week's class, we're going to paint in some grass, and it'll probably be a paint effects pass or something like that. And we're going to put little clumps of grass and stuff like this and some rocks in here to flesh out a little bit more of the forest and get it integrated into that. And that way it'll also have another layer to hide some of his ground interactions. I mean, they're pretty good, but as I go forward in the shot, there is a spot right here where his back foot is levitating right now, and that needs to have a rock that he was sleeping on that is going to have to cast shadows. It's going to have to be in there, and it's going to have to be under, and then he steps off and then he's fine. but we need a rock back there. Another thing is right through here is, that's a big move and it's moving a lot. And I don't want to add a lot of motion blur because motion blur kind of destroys 3D effect. But I want to add a little bit of motion blur through here. So we're probably going to look at like Nuke's ability to do optical motion blur based on vectors and such. And we're going to look at some options like that. Although it is kind of slow, we may just compute it for this particular section. So we're going to look at adding some motion blur. We're going to look at adding rocks and grass. We're also going to be probably creating a particle system to add like some forest dust in some of the beams of light in the foreground, which will add some nice little bits to it. So here we are so far. Our shot is coming along. And after we do some final tweaking next week, we're going to be taking it into setting up our virtual reality environment, in which this is going to be the main event on the screen, but we're going to be building out our environment as well. So I'm really looking forward to seeing how all of this comes together. If you have any questions about this week's class or any other class, feel free to hit me up in the forums. And until then, thank you so much.